What I want to do now, I want to solve this problem when the block is not attached to the spring. Instead, it is placed against the spring. So there is no this point that I draw to emphasize that it is attached. So here's the block. It is placed against here. Actually, here it is at equilibrium, but here I really need to remove this dot, and what's happening now, it is placed again. The rest is the same. So the block is placed against the compressed spring. The spring is compressed by amount of A. It starts, then it is released from rest, and it stops at some point. I need to find where will it stop. All this is same. Now change in kinetic energy is still 0. No changes here. Where is the change? Oh, look at this. So I compress it. I placed the box against the spring. But when I release it, it's not attached here. So the spring will return to unstretched position. And that's it. But the block, if friction is not strong enough, so let's assume that the friction is not strong enough to stop the block somewhere here, the block will keep moving without the spring. That's the difference. So I cannot write one integral anymore because the limits of integration will be different for force of spring and force of friction. Let's find work done by each force separately. What is work done by the spring? It will be from minus A, the spring will return to equilibrium and will not move any further. So it is minus kx for the force of spring, and then dx minus kx dx. I take this integral. It is minus kx squared over 2. The limits are from minus a to 0. I did not erase this line because we will use it later. So I will continue right here. I plug in the upper limit. It is 0. Then minus for the lower limit. Minus is plus. And minus a squared is a squared. So it is ka squared over 2. Ka squared over 2. Does this make sense to us? Yes, because the force of spring is to the right and the displacement is to the right. So work done by force of spring has to be positive, and it is. So work done by force of spring is ka squared over 2. Now what is work done by friction? It's integral. I start at minus a. I move to unknown xs, and again we assume that the block will manage, friction is not strong enough, and block will manage to travel here to the right. So it is minus a to xs. Force of friction, I need F sub x. It is minus mu n, where n is mg, minus mu mg dx. It is minus mu mg x. And I plug in the limits. Okay, let's not skip steps from minus a to xs. And this is equal to minus mu mg x is xs minus and minus lower limit plus, minus for lower limit and minus a plus. And this is work done by friction, which makes perfect sense. Look at this. So the force of friction opposes the motion, so it is to the left. Displacement is to the right, so sign is negative. And what is magnitude of the force? What is magnitude of work done by the force of friction? it's force itself, mu mg, times displacement. And displacement is xs plus a. Even without integral, we know the result because force of friction for this problem is constant force. We can take it out of integral and figure it out without writing it. But I just wanted you to have the full picture. That's why I put these integrals together. Great. What's the next step? Next step, let's use work energy theorem to solve for xs. Work done by the spring is Ka squared over 2. Work done by friction is minus mu mg xs plus a. And this is equal to 0 according to the work energy theorem because change in kinetic energy is 0. Can I solve for xs? Yes, we definitely can do it. So this guy will come to the right, and xs, I will use red for that. xs will be equal to minus a, and then plus Ka squared over 2, Ka squared over 2, and divided by mu mg. We found xs. Does it make sense to us? Let's think about it for a second. What if I don't have friction? Mu is 0. If there is no friction, how far will this block move? If there is no friction, it will be moving forever. Nothing will stop it. So what should be xs then? It has to be infinity. If mu is 0, then 1 divided, I'm sorry. If mu is 0, then 1 divided by 0 is infinity. And yes, it works. We understand what's going on. But since there is friction, it will be minus a plus this coefficient that we calculated. And please pay attention that we express our answer in terms of what is given. A was given, mu is given, mass was given, and K was given. Problem solved.